welcome back to Air Quality and Pollution. Today we're going to talk a little bit more in depth about the effects of air quality and pollution and what we're currently doing about it to make our air as good as possible. So there's a couple of different effects of air pollution on our bodies. There's short-term and long-term. Short-term health effects include headaches and nausea, irritation of the ears, nose, and throat, tightness in the chest, coughing, respiratory infections, and it can make pre-existing conditions like asthma or emphysema, it could make it worse. So there are some health effects if you're exposed to air pollution during your lifetime over a long period of time, or even if there's an event where you experience air pollution for a brief period of time. Long term, if you're exposed over a long period of time to air pollution, you could develop emphysema, you could develop lung cancer, heart disease, and any other conditions that older people or young children may have could become worse because of the air pollution. And as young children and babies are developing, it could damage their lungs as they're trying to develop. Outside is not the only place that we find air pollution. We're starting to learn more and more about the dangers of air pollution inside our homes as well, which may be a little scary now that you're locked inside your house. Anyway, sometimes the air quality inside our homes can be worse than the air outside. The chemicals that we use to clean our homes, the paints that we painted our walls and our furniture with, the chemicals in the carpets and the wood could all be outgassing into the air that we're breathing. In fact, if buildings have really poor air quality, they could be labeled as having sick building syndrome. There have been some brand new constructed buildings that have had lots of trouble with sick building syndrome because of the brand new varnishes and epoxy and the stains and the paints and whatnot that have made people that then move into the buildings and either live there or work there, if it's an office building, have made them very sick. Older buildings could have problems with mold, and mold could be a natural but a source of air pollution and irritation for people. Sick building syndrome is actually most common in warm climates because our air conditioning in the building causes us to want to seal up that building real tightly and prevent heat loss, or prevent the cold air, prevent heat from getting in, and keep ourselves cool in the summer. So the best defense against sick building syndrome is to improve ventilation, either vent it to the outside or have a little bit of ventilation into the building, if you can do that without heat and air conditioning loss, so that you move that air around. So in the diagram down here, you can see several different sources of indoor pollutants, whether it's carbon monoxide from the garage that's out next to it, animal dander, chemicals from the cleaning products, cigarette smoke, paints, solvents, lots of different sources of indoor air pollution. One that you'll hear talked about nationwide, not necessarily here in Texas, but in other parts of our nation, is radon gas. And radon gas is surprisingly actually the second leading cause of lung cancer in the United States. That's second, of course, to cigarette smoking. And radon is produced by the decay of uranium. So in areas where you have basements and areas where you're building houses right on a rock foundation, around here it's just all sand and sandstone, but where you have that rock, where you have that uranium in the rock, especially rocks like granite, then you get radon that is released from that decay of uranium. And radon is a colorless, tasteless, odorless gas. You don't realize it's there. You have to have an actual detector to detect the presence of radon. But it does seep into the homes either through the foundation or in the walls of the basement. It can adhere to dust particles, and whenever people breathe that in, it can damage the cells in their lungs. So they have to have detectors, and you might even have to you might have to figure out how to remove that radon and prevent it from getting into the house. Here's a map here, and this is what I was talking about, not in Texas. We're in zone 3, very low potential. You see the yellow right there, very low potential for radon. But other areas where they have that granite exposed, they're building right on it, not a lot of sandstone in between, lots of uranium that's exposed, or not uranium, it's not like they're radioactive, but uranium in the rock that they're building their home on, as well as areas with basements. That's where you tend to get more likelihood of radon exposure. If you have an older home, like much older, or an older business, you may have heard people talking about asbestos, either checking for asbestos or having to do special things when they remodel a home because of the asbestos. Asbestos is long, thin fibers that make up a mineral, and you can see down here at the bottom there's several different minerals that occur in those long, thin fibers. For a long time, people used asbestos when they were building buildings and homes because the fibers were very strong and they were heat resistant. So they would actually use it for fireproofing, insulating, fire retardant, all that good stuff. The school that I went to, that was built in the 30s, had it in the floor tiles because it provided a heat resistant barrier in those floor tiles. Now in the early 1970s, it was banned completely. And since then, we have spent billions of dollars removing it from buildings. Now, if it's not disturbed, it's not a problem. The problem is when it is drilled into or ripped up for renovations or cut with a saw. The problem is when you disturb it. So any renovations that have to be done very carefully. The problem with asbestos is those long, thin fibers are like tiny little shards of glass, basically. If they're inhaled, they can cause scarring in the lungs, which can lead to lung problems, like actual, almost like cancers. Another problem that we get with pollution in the air is another thing in the air is water, and so that pollution, the nitrous oxide or sulfur oxide, can latch onto a water molecule and cause acid precipitation. Now, you always hear acid rain. It could also be snow or sleet or hail, so they just kind of use a blanket term of acid precipitation. Most of the sulfur and nitrogen is going to come from fossil fuels, either gasoline, coal, diesel, whatever, but some kind of petroleum. And that sulfur and nitrogen will combine with that water vapor to produce sulfuric acid and nitric acid. And then when it rains, then that acid falls to the ground as acid precipitation. Now remember, acids and bases, pH is a measure of how acidic or basic a solution is. We should have water that's around a 7. Less than 7 is acidic, higher than 7 is basic. So acid rain would be somewhere around the 6, maybe 5, but I haven't heard many cases of it getting lower than that. The problem is when those acids collect in the soil and in the water sources, the rivers and lakes and streams. So when the acidity of the soil builds up, when you lower that pH, that's called acidification. And it can directly damage plants and fish if you're if you're acidifying a river, lake, or stream. But it can also, in the soil, cause minerals to be leached out of the soil, and that mineral removal can cause root damage to the plants that are trying to grow in it. So ecological effects of acid precipitation, that acidification can directly kill the fish. If it's soil, it can leach out. That's what we were just saying. You actually get acidification happening more in the spring when snow melts, and then all that water runs into rivers and lakes all at one time. So if you just have rain events or snow events a little bit at a time, then it's not so shocking to the fish. But in the spring, when it all melts, all of that snow that has all of that acid in it rushes into the rivers and lakes at one time, you get acid shock, and then you can get fish kills, very sudden dying events of fish all at one time. Now, acid precipitation does affect us too, affects humans. Those toxins that are leached out of the soil can make their way through the food chain and can poison us. That acid precipitation could affect our respiratory systems. Of course, fish kills are not good. That's less fish for us to eat. That can work its way through the food chain as well. But if you see this little picture over here on the right, acid reacts with calcium carbonate. Calcium carbonate is found in concrete, limestone, and marble, and causes it to dissolve. So that calcium carbonate that we make buildings and statues and gravestones out of eventually begins to dissolve away, like you see in this picture here, because of the acidity wearing away at it and causing that calcium carbonate to react. All right, a surprising type of pollution that we're throwing into air, because I wasn't sure where else to put it, is noise pollution. So noise pollution is classified as any unwanted irritating sounds that could damage our hearing, destroying the cells in our cochlea. But it can also disrupt animals on land and in oceans. It can cause problems with fish that are trying to swim or turtles that are migrating, and really cause confusion. Now, noise intensity is measured in a scale called decibels. Each increase of 10 decibels is 10 times the intensity. If you get to 120 decibels, you can see over here on this chart right there, 120 decibels is called the threshold of pain. Anything higher than that would damage the hearing of the person that's around there. So noise pollution could come from industrial sources, could come from traffic, could come from construction. There's a lot of things that we can do to regulate and reduce the volume, the problems of noise pollution. Mufflers on vehicles is one of those. Regulating the volume of headphones. You might notice headphones won't go up as high as they used to. Increasing insulation in buildings and creating barriers around construction sites. Those all reduce sound, which helps reduce that noise pollution for all of us. Light can also be a pollutant. Light pollution can cause headaches and fatigue and stress and anxiety. And it can also cause problems for animals too. Hatching sea turtles and migratory birds get confused by the light that they think is sunlight or stars, and then they can't migrate or travel like they should. And of course, too much light is wasting energy, right? So there's a couple ways that we can mitigate light pollution. One is shielding the light to direct it downward on the streets. Of course, you don't want a completely dark city. That's dangerous, but directing it down to the road itself and not just shining in all directions. Using timers, time controls, and using lamps that are more efficient. So controlling pollution takes a lot of cooperation. Air moves, it drifts, it blows around. So we have to cooperate with other countries. One example of this would be the Canada-US Air Quality Agreement, but this is just one example. There's many others. Here in Texas, we monitor and enforce air pollutant rules. We collect air quality data with special equipment, and I have a video for you to watch. EPA has identified 6 criteria pollutants that they monitor for, and we use special equipment to collect data on that, and then our local or our state agency, the Texas Commission on Environmental Quality, takes that data and looks at any additional regulations that or laws that need to be passed in order to keep everything safe. So go to that video, watch it real quick on how they monitor, and I will see you next time. Send me your questions if you have any.